We make industrial-grade sorters for pistachios and similar-sized grains. These grains are fed to a moving conveyor belt to gain the proper velocity. As our objects of interest reach the point of departure, bypass the pneumatic ejectors, they are being watched by an array of sensors and high-speed cameras from top to bottom. We have only a fraction of a second to set the right flight path for every single grain. The default path sends them to the accepted output, but we can choose to deviate them toward the rejected one. To identify every aspect of grading a pistachio, we spent several hundred hours consulting experts and major producers, and then several thousand hours gathering datasets for artificial intelligence models. For some of the more challenging subjects, every image was confirmed by at least 3 individuals before making it to our training pipeline. Artificial intelligence models can accurately describe a pistachio from an expert's point of view to identify defects such as crinkle shell, adhering hull, and light or dark stains. Combined with a few more intuitive classic features, such as color composition, size, and angle of shells, we can decide if a certain subject meets user-defined standards. For every new batch of workload, these standards are fully customizable through a user-friendly GUI. Probabilistic nature of artificial intelligence models allows us to adjust the level of scrutiny for every defect. On the other hand, we can take decisive actions using computer vision algorithms that measure the size of an object with a precision comparable to calipers. As the pistachio is still airborne, different observations from different sensors are grouped to form a unified object. This will help to make a better decision by inspecting every angle of every input, and also come in handy for calculating target trajectory in case we need to activate the pneumatic ejectors. We can break down our judgment process into 3 steps. First, an artificial intelligence model filters out clutters to free processing power for the real objects of interest. Then, several artificial intelligence models, each one specialized in finding a distinct flaw, run in parallel and cast their votes in real time. In the end, up to 10 distinct data points for each grain, each one containing a vector of artificial intelligence generated and computer vision measured features, are fed to a final decision-making artificial intelligence model to create a single feature vector for each object, which will be compared with user criteria. This leaves a few precious milliseconds for our control units to calculate the exact time and place of the arrival of the bad grain. At this point, everything happens so fast that we even have to account for the time it takes the air to travel from the air compressor to the pneumatic ejectors.